Hello, chemistry students. We're now ready to finish up our topic on the states of matter, and today we're going to be looking at phase changes. We're going to see how the addition and removal of energy can cause a phase change, and also what is a phase diagram. And so here we go. Notice again we have our three common states of matter. We have solid, liquid, and gas. Also notice that as we go to the right, we are showing an increase in energy, and so you can think of this as adding heat to the system. And so notice there are three different types of phase changes that require energy. The first, taking a solid to a liquid, and so this is referred to as melting. Taking a liquid then further to a gas is known as vaporization, and we also have the situation where we can go directly from a solid to a gas without first going through the liquid, and so this is referred to as sublimation. And so let's look at each of these three first. Melting. Heat is the transfer of energy from an object of a higher temperature to an object of a lower temperature. What happens then is the energy that is absorbed by this ice, for example, is actually not used to raise the temperature of the ice. And so there must be something else at work here, because we know from the law of conservation of mass that energy as matter cannot be created nor destroyed. And what's going on now in this situation is that the energy is being used to loosen the hydrogen bonds that hold the ice together to a point where now the molecules will enter into the liquid phase. And so the temperature that requires this to happen is referred to as the melting point. And so remember that for water, it's going to be approximately 0 degrees Celsius. We also have another process of vaporization, and so as more energy is added to the liquid water, some particles will escape and enter into the gas phase. And if you look at the word vaporization, you will notice the word vapor. And so that's exactly what's going on in the case of water. And so we're going from liquid water to water vapor. And once the vaporization occurs, only the surface of a liquid will show what is referred to as evaporation. And so, for example, we have in our own bodies a way to cool ourselves down. What we have, we put sweat down on our skin. The sweat is cooler than our body temperature, and so the heat will be transferred from the hotter body temperature to the cooler water, and so the water will evaporate, so it will then enter into the gas phase, and by doing so, we're also drawing heat away from our bodies. And so a very ingenious way for us to cool down our bodies in order to maintain that very important idea of homeostasis. All right. The boiling point, therefore, is the temperature at which the vapor pressure of a liquid is meets that of the vapor pressure of a liquid of the external atmosphere. And so for water, that would be at 100 degrees Celsius. Sublimation is a third type of phase change that requires energy. This is where we can take a solid and directly change it into a gas without first having to go through the liquid phase. And so a very good practical example of this is what we refer to as dry ice. Now, dry ice is a solid form of carbon dioxide, so the same gas that we're breathing out right now. What happens in room temperature, the solid dry ice will go directly into the gas phases. This is also very useful when they're trying to make a spooky setting where there's fog and something like that. They also use dry ice for this purpose. We can use dry ice that can be used then to help with food, keeping food fresh as it's transported across long distances. And so the next time you decide to send Grader's ice cream to a friend out in California, you have sublimation to thank for that. All right, hopefully no questions right now. We're going to also now look at the phase changes that release energy. So notice we're going to now go to the left. So we're actually showing a decrease in energy. And so we again have our three phases: gas, liquid, solid. Notice that when we cool things off for a gas, it will then enter into the liquid phase, and so we refer to this as condensation. If we further cool the liquid down, we will then see it go into the solid phase, which we refer to as freezing. And we can also have the situation where we take a gas, convert it directly into a solid without first going through the liquid. This is referred to as deposition. And so all three of these changes result in the release of energy. We'll start first with condensation. And so when water vapor molecules lose energy, its velocity is then going to be more likely to collide with the container of the water molecules. And so a good example of this is when you're taking a shower, and when you're done, you step out and you look at the mirror and you start to see these water droplets form on the surface. And so what's happening, the glass is cooler than that of the shower water, so it's going to cause the phase change referred to as condensation. And so you can also see this in the summertime. If you leave a drink out, you'll start to see the characteristic water bubbles on the outside of the surface. And so this is also an example of condensation. Deposition is the opposite of sublimation, and so this is where we're going from the gas phase directly to the solid phase without first going through the liquid phase. And so in the wintertime, which it seems kind of strange that the farmers would do this down south, but they will spray their crops with water over the winter to insulate them from freezing. And so what happens is water, being of a high specific heat, is going to hold in more than any other type of substance, and therefore it will keep it from the crops from freezing, and so which gives kind of an interesting effect down south. And so also snowflakes form when water vapor is high up in the atmosphere, and it changes directly into solid ice crystals, and so without it first going through the gas phase. We'll now talk about the sixth type of phase change, which is freezing. And so as liquid water molecules lose energy, they lose velocity and are more likely to run into each other. And so when enough energy is removed, the molecules and the hydrogen bonds between the water molecules will keep the molecules fixed or frozen into the set positions. And so freezing is the reverse of melting, and we can also define the freezing point as the temperature at which a liquid is converted into a crystalline solid, which again for water would be 0 degrees Celsius. And so notice that both the freezing point and the melting point for water is 0 degrees Celsius. It just depends upon the direction, whether you're adding in heat or you're removing heat, but the temperature for both the melting point and the freezing point is the same. All right, our last topic for today, we're going to be taking a look at a phase diagram. And so a phase diagram is specific for a different material. On the left here, I have one for water. On the right, I have one here for carbon dioxide. Notice, as the name might suggest, a phase diagram contains solid, liquid, and gas. And there's also a couple other points of interest I want to point out. And so notice that the temperature increases as you go to the right, and the pressure increases as you go up. If we look, for example, here at point A, you will see the intersection of the solid, the liquid, and the gas phases of water. And so this is referred to as the triple point. And so the triple point is the point on the phase diagram that represents the temperature and pressure at which all three phases of this water can exist simultaneously. And notice also here, we also have the triple point for carbon dioxide over here. Also, there comes a point where you can no longer liquefy a gas no matter how much pressure you exert on it. So again, as you're trying to get the molecules closer together in order to make it into a liquid, there will come a point where you can no longer do that. And so what we refer to this as is the critical point. So the critical point is indicated the temperature and pressure above which a substance can no longer exist as a liquid. And so point C here on this graph is the critical point for water, and for here, this would be the critical point for carbon dioxide. And so based upon both pressure and temperature, we can then observe the different types of phase changes. So for example, if we have water, and we're going to keep this at the normal atmospheric pressure of 1, if, for example, we start down here, we're going to see that we are, in fact, in the solid phase. We keep adding more heat, and so it's going to cause us to keep going up this way. Eventually, once we hit 0 degrees Celsius, we will see a phase change from solid to liquid, and yes, that liquid, which again is referring to melting, so this is where it's going to melt right at this point. We can then continue to add heat, and that'll then turn the liquid then into a gas, and so notice that that temperature for water is 100 degrees Celsius. And so we can also then remove heat, so going from the gas to the liquid would be condensation, going from the liquid to solid would therefore be freezing. And so I also wanted to point out the situation we talked about earlier when it came to sublimation. We have, for example, for dry ice, which again, if you remember, is carbon dioxide, if we have at normal atmospheric pressure, which is 1 atmosphere, if we have the temperature increase, notice that once it hits roughly negative 78 degrees Celsius, there is a phase change from the solid to the gas, and remember this is referred to as sublimation. And so this shows you why carbon dioxide at this pressure will sublime instead of melt. And so hopefully that makes sense. And so what I'd like you guys to do for homework tonight, go ahead and please on page 430 do problems 27 through 30. And so this is Dr. S signing off.